The next mental task, I'm going to keep using carbon for this experiment right here, or this exercise right here. So we say, hey, I know the molar mass of carbon based on a periodic table. It's 12 grams per mole. Meaning what? Every mole of carbon atoms, if I put it on a scale, okay, if I put 1 mole of carbon atoms on a scale, then the scale should display this number. Okay? All right? If you go to, if you say, hey, what about potassium? What about potassium, which is atomic number 19? What's the molar mass of potassium? Okay, so that means if I have 1 mole of potassium atoms on a scale, the scale should display this, right? Okay. Now I'm going to play a little game, just like the speed game, and that is if I have 2 moles of carbon atoms, what would you expect the scale to display? 24, right? Can you see how you don't question like, oh, do I multiply or divide? You just know that there shall be 24 grams of carbon atoms. Okay? If I say, hey, what if there are a total of 60 grams of carbon atoms? Then 5 moles. Okay? Now, what if I have 0.5 moles of 0.5 mole of carbon atoms? 6 grams. Okay? Now, why am I playing this game with you? Because one thing that it's usually not taught in class, and that is actually very crucial, it's the way you can approximate values. They don't teach you this. Why? I don't know. But it turns out that it is very essential that you know how to approximate these values. Okay? So now, if you understand that 12 grams of carbon, I'm going to drop the word atoms because by writing C, you know it's for atoms. So 12 grams is to 1 mole. 12 grams of carbon is to 1 mole of carbon, right? Now, I want to share with you this. I teach this to my SAT students, and it's just a general common sense knowledge that I expect every high school student to know. And that is, you know 10% of every single number. What is 10% of 12? 1.2, right? So 1.2 grams of carbon is to 0.1 mole. Right? So if I somehow say, oh, what about 3.6 grams of carbon? Then you would say, oh, it's going to be 0.3 mole of carbon atoms. Okay? Little mental math. And I hope you can witness what's going on right here. And that is, you did not do so-called railroad track dimensional analysis to puke out these numbers. Your brain just knows because it makes sense. Now, and I would go ahead and say, all right, now, if I do give you 3.6 grams, how would you show your teacher the work? Well, you know the answer already. It's going to be 0.3 mole. Or in a more simpler sense, you know this amount of grams of carbon must be less than 1 mole. Right? Because you know 1 mole of carbon atoms would be equivalent to 12 grams. This is less than 12, gotta be less than 1 mole. So now I'm giving you 2 safety measures to check your work. Number 1, like your teacher tells you, match up the units. Right? The grams would get canceled out. The second safety measure is you know the answer already. You know the number of moles got to be less than 1. So the only way that this computation would make sense is that 3.6 is divided by 12, not multiply. Because if you multiply, let's see, 3.6 times 12, 3.6 times 12, it's going to be 43.2. And you'd be like, wait, what? There are 43.2 moles? No way. That doesn't make sense. So a lot of people, they screw up right here with this kind of calculation. It's simply because they don't know how to feel the meaning of the number, the molar mass number. But once you dive deep and fully understand what molar mass is, it's going to be very straightforward. Okay? Good? Now, if you're good, then let's go ahead and dive in a little bit deeper about this ratio. What is this ratio? It's basically a link between mass and quantity. And this quantity will be in terms of groups, which we call moles. Okay? And this is what we call dimensional analysis. Mass is a dimension, quantity is a dimension, so this ratio relates two different dimensions together. Just like what we said earlier about speed, we have distance or length as a dimension, we have time as a dimension. Therefore, when I say 60 miles, you know it's 2 hours. That's the beauty of a ratio. If you know one number, you must know the other number. And you must know how to make sense with the number. Okay? So far, so good? All right, now, if this is good, then we're going to move on to our next task.